Okay guys, here we're going to do a lesson that's discovering what's going on with inverse functions in calculus. So this is all about inverse functions. Let's start off by graphing this function f of x, and then we're going to graph this function right over here, g of x. Graph the f of x function right here. I know it's a parabola, so it starts off here at 2 because it's going right there. And then the next point's probably up 4 from the 2, and it looks something like that. Just need an estimated graph right here. And then we're going to graph the g of x function. This is a square root function. So this negative 2 means it moved to the right 2. So let's move this radical to the right 2, and it looks something like this. So there. So I graphed the f of x, I graphed my g of x, and now ask me a few questions. First ask, how do the graphs compare? So what do you guys think? How do the graphs compare? Write down what you think here, but to me it looks like they're similar graphs. Very similar. Oh, it's not working for me. This pen works or graphs, but there it looks like it's rotated and flipped, maybe something like that. Something's going on with them. Right, rotating, flapped. Do the graphs pass step 3? Do they pass the vertical line test and the horizontal line test? Let's see if they do. We'll get a line on here and see what's going on. So this one looks like it does pass the vertical line test, and the red one does too. Perfect. Let's rotate that around. See if they pass the horizontal line test. Sure enough, they do. They pass the horizontal line test. I wonder what I'm trying to get at with those questions here. Let's see. What does this mean in terms of it being 1-to-1? Well, I guess if they both pass the vertical and horizontal line test, that means their inverses are also functions. So both g of x, both f of x and g of x have inverses that are functions. That are functions. Okay, so now it says show that this equals that and this. Okay, we'll do that. I wonder why we're doing that. Okay, let's do that. Let's find f of g of x. Well, let's do this one first, and then we'll do this one second one. We're gonna find f of g of x and see if it's equal to x. So f g of x, I forgot what g of x was. That's square root of x minus 2. Square root of x minus 2. Let's see what that equals. Well, that's equal to, every time I see an x in my f function is x squared plus 2. I'm going to put in my g of x function. So I start by that straight up. I put in my x minus 2. I'm going to take that whole thing and square it, and then I add 2 to it. So that's f of x minus 2, or the square root of x minus 2. Notice that this square and that square root cancel. So I have x minus 2 plus 2, which is equal to x. So that one checks off for this first one right here, right? That one checks off right there. Let's do the opposite way. Let's put my f of x function into g of x. So I'm finding g of x squared plus 2. Well, that means every time I see an x in my g function, I'm going to replace it with an x squared plus 2. So I have the square root. I see an x, so I'm going to put an x squared plus 2 minus 2. The inside simplifies down to being the square root of x squared, which is just x. So that checks off too. So what does that mean? That f of g of x equals x and g of x equals x? Well, because of this last statement right here, 5, because we showed that f of g of x is equal to x and g of f of x equal to x, we can say that f and g are inverse functions. So they're inverses of each other. Okay, they're inverse functions. And g, this g function right here, can be written as f inverse of x. Okay, this -1 right here does not mean raised to the -1 power. That means inverse, guys. So be clear on that. Okay, so let's go to number 7. Number 7 is 2, 6 a point on f? Let's see if it is. Let's just plug in the 2 into the f function. So we have 2 squared plus 2, which is equal to 6. So that checks off. 0.26 on there. And is 6, 2 a point on G? Well, let's take the square root and put the 6 in for the x minus 2. 6 in for that x, and we get the square root of 4, which is equal to 2, and that's that 2 right there. So that checks off 2. Great. Next, we're looking for f prime of x, and then we're going to see what's going on with f of 2. That's interesting. And we had this 2 right there, right? So I'm going to try to figure out what's going on with f prime of 2. First, we've got to find f prime of x. That's not too bad. F prime of x is equal to 2x, right? Because if you take the square root of the x squared plus 2, that's just 2x. So then we can find that f prime of 2. F prime of 2 is equal to 4. Okay. Let's see what's going on with this g. It says find g prime, and then later find g prime of 6. Oh, notice that there's a 6 here. That's interesting. Wonder why that is. Let's find it. Let's see. G is a little bit tougher. The derivative of g is, I think if I remember correctly, it's 1/2 x minus 2 to the negative 1/2 times the derivative of the inside, but the derivative of the inside is just 1. So this actually simplifies to being 1 over 2 square root of x minus 2. And now we're going to find that g prime of negative 6. So we'll just plug this 6 in for that x right there. So I got 1 over 2 square root of 6 minus 2, which is equal to 1 over 2 times 2, which is 1 over 4. I kind of skipped some steps in here, but notice that 6 minus 2 is 4. The square root of 4 is 2. That's where that 2 came from right there. Okay, so we got 1/4 for that one. For the last one, we got a 4, and then this one gave us 1/4. So next, part 9 says, hey, are there any relationships between the derivatives of the inverses? Well, let's look at them. The derivative of this inverse was a 4, and the derivative of this inverse was a 1. Oh, not that. It was a 1/4. So I guess they're flipped. Yeah, there is a relationship. It looks like they flip. And in math, we call a flip a reciprocal. So it looks like they're reciprocals of each other. I wonder if that's always the case. Let's see. I wonder if that's always the case. Well, in this next example, we're going to try an example and see if something like that happens. Is the end result going to be a reciprocal? That's what we're going to look for in this next example, okay? Okay, so here are the kind of steps for determining what's going on with these inverse functions. First, the step is given that f and g are inverse functions, so that's given. We are going to start by knowing that f of x is this, and we are going to find the derivative of f of x. So the derivative of f of x is, we'll start by just changing it. Well, actually, no, we could do this. We got 1/2 of x to the third plus 1, all raised to the negative 1/2 power, and then the derivative of the inside is just 3x squared. Okay, so if I were to simplify this down, f prime of x is equal to 3x squared all over 2 times x to the third plus 1 to the 1/2 power down there on the bottom. So there, that's the first thing. And then it says find f prime of 2. Okay, we're going to find this f prime of 2. Now I want you to think about something. For finding f prime of 2, and you plug 2 into this function right here, the point when you plug 2 into that function, you get 8 right here plus 1, and you take the square root of that, you get a 3 here, right? Okay, so you're finding the derivative at 2 when the original function is at 2, the point 2, 3. Okay, so let's find f prime of 2. We're going to plug that 2 into the function right up here and right there. So we got 3 times 2 squared all over 2 times 2 to the third plus 1 raised to the 1/2 power. Notice this 2 and that 2 cancel. So I have 6 all over this bottom right here becomes 9 to the 1/2 power. And that's 6 over 3, which is equal to 2. Okay, so the slope at 2 on the function f is equal to 2. Okay. And remember what we found. It seems like the slope is a reciprocal between those points, between these 2 points here. What's going on with those? Let's see if something similar happens here. Okay, so now we got to find g, the g function. So what we need to do is we got to find the inverse function. We know that g is the inverse of f of x. So to find the inverse function, but you just swap the x and the y. Here's your y, here's your x. We're going to swap it. We're going to solve for the y that's going to be there then. Okay, so let's see if I can translate that down here. I have y is equal to the square root of x to the third plus 1. Step 1, swap them. Swap x and y. So x is equal to the square root of y to the third plus 1. Next, let's get rid of this radical right here by squaring both sides. So x squared is equal to y to the third plus 1. Now we're going to bring this 1 over here by subtracting it. I got x squared minus 1 is equal to y to the third. And now we're going to take the third root of both sides. And when we do that, we have y, which is g, right? That's our g function, g of x. Y is equal to, we'll just write it right up here. G of x is equal to the third root of x squared minus 2. Now we don't have to put a plus or minus in front of here. The reason being is the third root is a positive or an odd root, and that's why we don't have to worry about that plus or minus situation. But if you're taking the square root or anything like that, fourth root, sixth root, eighth root, plus or minus is required in front. Okay, so we got our g of x function. And now it says find the derivative of that function down here. So let's find the derivative of g of x. The derivative of this, we bring that 1/3 in front, right? The inside stays the same. X squared minus 1 raised to the negative 2/3 because it dropped by a power. Then the derivative of the inside is equal to 2x. So multiplied by 2x. Right? Multiplied by 2x. And let's simplify this down here. This is equal to 2x over 3 times x squared minus 1 to the 2/3. So we got our g prime of x is right here. Next it says find g prime of 3. Oh, did you guys see 3 anytime in the near past, in the recent past? Yeah, we did. Check it, it's right up here. See it right there? Crazy. What's the chance? What's the chance of that? Yeah, find g prime of 3. So let's find that g prime of 3. We're just going to plug this 3 into the x there and that x there, and then let's see what we get. So we got 6 on the top when we plug it in up there, all over 3. Oh, I should have just canceled those. I guess I'll do that later. Times 3 squared minus 1 raised to the 2/3 power. This is equal to 2 over 8 to the 2/3 power. And right here, this 2/3 power, really what it's saying is take the third root and then square it. Well, the third root of 8 is 2, and then squaring 2 is 4. So we got 2 over 4, which gets us 1/2. Check it out. Here's our 1/2, and here's our 2. And notice how they're reciprocals of each other. If you can see those, yeah, they're reciprocals of each other. So, what conclusions can we draw from this? Draw any conclusions about f prime of 2 and g prime of 3? Well, here's what conclusions you're supposed to draw from this. F prime of 2 is equal to the reciprocal of g prime of 3. So f prime of 2 is equal to 1 over g prime of 3. And g prime of 3 is also equal to the reciprocal of f prime of 2. So g prime of 3 is equal to 1 over f prime of 2. Okay, we're going to use this idea right here. This is big. to solve all the rest of these problems right here. Example 2, example 3, example 4, and example 5. Okay, so that's going to be the next step in the process. Okay, in this problem, they're giving to you that f of x is equal to the square root of x minus 4 for when x is greater than negative 4 or greater than or equal to 4. And the reason they say that is because you can't take the square root of a negative, so they're just saying you just have to have this be greater than 4. And then they're letting you know that g is this inverse, and they're saying, hey, find g prime of 1. Well, if we went back to this last problem, right, we found that g prime of 3 is equal to 1 over f prime of 2. So we know that g prime of 1 is equal to something in relationship, the reciprocal in relationship to this, the derivative of the f function. So we know it's 1 over f prime of something. What's that something? That's the key thing. We got to find that something. And then this is an easy problem. And it's not too hard to find that something. If you think about it, reciprocals, if you have a reciprocal function, if this is your x for your g, that's your x for your g, it's actually your y for the reciprocal function. Okay, so if 1 is the x for the g, and it actually turns out to be the y for the reciprocal function with this, we know that f of x in this situation is 1, and we can solve for the x at that point. If that makes any sense. So we know that this 1 for my f function represents the y 1. We just got to figure out the x at that point. What is the x? And whatever that x is goes in here. Okay, so what we do is we just take this 1, plug it in for the y here, and solve for the x. So we got 1 is equal to the square root of x minus 4. Since 1 is equal to the square root of x minus 4, we have 1 is equal to x minus 4. That was the easy step. And therefore, x is equal to 5. So we found what the question mark is. The question mark was 5. So we know this is equal to 1 over f prime of 5. Okay? Now let's just find the derivative and figure out what f prime of 5 is. Well, so the derivative of this function, f of x, is equal to f prime of x is equal to 1/2 times x minus 4 raised to the negative 1/2 power. So that's 1 over 2 times x minus 4 raised to the 1/2 power. Now let's find f prime of 5, which is what we're looking for right there. F prime of 5 is equal to 1 over 2 times 5 minus 4 to the 1/2 power. This is just 1 over 2. Because 5 minus 4 is 1, square root of 1 is that, so 1 over 2. So we know that this f prime of 5 is equal to 1/2. So we can say we have 1 over 1/2, which is equal to 2. Therefore, g prime of 1 is equal to 2. So that's kind of the flow of doing a problem like this. Step 1, they're going to give you, right here, this x value for your reciprocal function, okay, your inverse function. Because it's an inverse function, you know this x value represents a y value on the inverse function f of x. So you plug this in as your f of x function, you solve for this, and then you get your x coordinate. And that coordinate is the coordinate you're going to plug in for the derivative function right there. Let's try another one, because this is probably confusing at this point in time. Let's give another one a shot right down here. Okay, in this next problem, they give us a trig function just to challenge us a little bit more. They say that f of x is equal to tangent of x. And they say g of x is the inverse of f of x. We want to find g prime of 1. Okay, step 1. Step 1 is to find the points that go through, that this f of x function goes through when y is equal to 1. Not x, y. Remember, f is the inverse of g. So since this is the x for g, it's the y for f. Okay, that makes sense. So let's see this. F of, we know this goes through 1, but we don't know the x value for when it goes through 1. And we know our g function, it goes through 1 comma, we don't know, but that doesn't matter. We don't need this part of it. Okay, so let's find out what this question mark is, because g prime of 1 is equal to 1 over f prime of that question mark. Got to figure that out. Okay, so let's find it. We're going to take this 1 right here, plug it in for our f of x. So we have 1 is equal to tangent of x. Now you got to go back to your good old unit circle days. What when does tangent of x equal to 1? Well, that happens, remember all students take calculus, so this is the positive. All students take calculus. This happens at square root of 2 over 2. Am I right on that? No, square root of 2 over 2, square root of 2, pi over 4. It happens at pi over 4. So we know that x is equal to pi over 4. And if you don't remember that, you can put it in your calculator and try to figure out. You can do that tangent inverse, right? Tangent inverse of 1 equals x, and I think that will give you pi over 4 will just be as a decimal of some sort. But if you can remember your unit circle, it's very useful. So pi over 4 for tangent of our question mark. So we know that this f function goes through the point pi over 4, 1. Okay, we're going to use that. I'm going to put that in for this question mark here. So we know that g prime of 1 is equal to 1 over f prime of pi over 4. Now let's find the derivative of our f function, and then plug this into it, and then we can plug that value back in there and see what we get. So f prime, okay, f prime of x, we got tangent, so we do the thing, derivative of tangent is secant squared. So f prime of x is equal to secant squared x. And what we want to do is we want to find f prime of pi over 4. That's equal to secant squared of pi over 4. I never remember what secant is of pi over 4, but I do know that secant is equal to cosine. So I know that this, or 1 over cosine, so I have 1 over cosine squared of pi over 4. And cosine of pi over 4 is actually square root of 2 over 2. So this is equal to 1 over square root of 2 over 2 quantity squared, which is equal to 1 over 2 over 4, which is equal to 2. It's a lot. I did that kind of fast. And good thing, you know, you can rewind this and double check it again and see what I did and find my mistakes. But I found what my f prime of 4 is, which is what it was this. It turns out to be 2. Therefore, g prime of 1 is equal to 1 over 2. No simplification needed. And that's how you do example 3. Okay, this next question right here is a classic AP question. They're not going to give you any functions to find the derivatives of or anything like that. They're just going to say, hey, we got two functions, they're inverses. They're going to say one function goes through a point, and they're going to assume, because you know they're inverses, that you know the other function goes through the point g, goes to the point 5, 2. So you know g of 5 is equal to 2. So the g function goes through the point 5, 2. The f function that I give to you goes through the point 2, 5. And you know the g function goes through 5, 2 is because this is the inverse of the f function. They're also going to give you a derivative at one of those points, either f of 2 or g of 5. Okay, they're going to give you the derivative of one of those. Okay, in this situation, they give me f prime of 2 is equal to 1/3, and they're going to say find g prime of 5. Now, graphically, what's going on here is, check it out, f of 2, f of 2, 5. So at this point on the first function, the f function, they say the slope is 1/3. So notice I have this 1/3 nice flat line. And notice here's your other point, your 5, 2 point. That's your g function. And we know that it should be the reciprocal, so we should have this nice steep slope right there. So you're looking at that, and you would say, oh, the slope's probably bigger than 2, less than a trillion, something in between there, between 2 and a trillion. So let's see if we can find what g prime of 5 is. G prime of 5 we know is 1 over, we swap the 5 with the 2 right there. So 1 over f prime of 2. Well, this is equal to 1 over 1/3, which is equal to 3. And 3 is between 2 and a trillion, so it checks off. There's really nothing to do with 2 and a trillion, but I just estimated right there. So that's how you do a problem like this. So first, you kind of estimate, or you're getting to a point, you're given a derivative and a slope at that point. Usually this value correlates to this point right here, and you got to understand that because their functions are inverses, you swap the x and the y value here up there. So that's how you do example. Okay, one last problem, guys. We'll call it a day. This is just like the last problem we dealt with. They tell us that f and g are inverse functions. They tell us that f of 1 is equal to -3. Because they're inverse functions, we know that g of -3 must go through the point 1. So when you go through the -3, 1. They tell us that f of prime of 1 is equal to 9/2, which is very close to 4.5. This is actually exactly 4.5. So that's a fairly steep slope. So if I were to go over here and graph that, it maybe looks something like this. And they say find g prime of 3. Well, we know that this will be the reciprocal of 4 over 5. So we know it's going to be something nice and flat like this right there. But g prime of -3, well, we don't know. It's the reciprocal. We're just guessing. Should be 1 over, hopefully give us enough information to swap 3 f prime of 1. Did they give us f prime of 1? Good. Yes, they did. F prime of 1, so we have 1 over 9/2, which is equal to 2/9. And that's a pretty flat line right there, just like I expected it to be. So that's how you do these problems, guys. I hope this makes sense. Again, I'll be gone today and tomorrow, so I'll have another video for you tomorrow. I think tomorrow's video is a little bit easier to, comprehend on how to do some of these. This is very abstract. It's a tough idea to think about. At least I think it is kind of tough. So good luck with it today. The homework assignment, the sub should have it for you. It's on the board. I think it's the last 3 problems on the AP worksheet that she has for you. So the last 3. And then I believe it's section 5.3, 71 to 79. And then I think it was 88 and 89. I think those. But don't quote me on it. Just what did the sub tell you? I'm just going from memory when I'm writing this down right here. So guys, have a great day, have a great weekend, and you'll hear from me tomorrow.